Hello, my name is Christian Hock from Siemens, as already Stefan mentioned, and I'm active working member in the PackML working group and a lot of other working groups. And today I want to show you the success from OMAC. Maybe you know OMAC, with their PackML specification, how it was going on, what was they doing. If you should not know PackML, what is PackML or OMAC PackML is a standard for packaging machines. The goal of PackML is to provide defined machine states, standard operational flow, overall equipment activeness, and root cause analysis for production data. So all those things, a lot of things they wanted to do, and they started around, wait, give me here, they started somewhere 1917 and they released in 2017 they started and they released in 2018. There was a lot of discussions in the OMAC group how to move the OMAC pack tags to OPC UA. Do we only do the pack tags as variables? Do we all the stuff, the objects, what are types? All those things was quite new this time. Like Andreas said before, with the VDMA now, the people are trained more and more, so the OMAC PackML was one of the first companion specs. They said, okay, we want to have an OPC UA interface. And the companion spec is nothing else than a higher level interface which represents your machine to the outside world for the different use cases. Each one could be the rubber machine. Now with PackML is for packaging machines. The global leadership of OMAC was also in the working group. We had a lot of active parties there. There was Tetra Pak on the beginning, and there was end users, there was machine builders in, and all of them, they had a different glue. How should the interface look with OPC UA? They had basically, even OPC Foundation had no clue how a packaging machine looks. So there was a very, very good cooperation together, a lot of discussing, and it took a while that everybody understood, oh, this is an interface and it's something, abstraction, which shows my machine to the outside world. The working group lead at this time for the version 1.0 was with Sari Germanos and Paul Hanger and Dennis Brundle as editors. And then after that we figured out, okay, like Siemens, Beckhoff, a few other companies tried to implement the interface, and they figured out there are some things needs to be fixed. So we started again the working group. This was a month ago, and we will bring out, I think, for the Hanover Fair 2020, the 1.10 with some fixes. The most of the fixes we need to do was typewriting mistakes. So there was like a value, it was Laue, something written, and nobody recognized it, but then when you implement it, you say, okay, should we leave it with this name, or should we change it? Or some references was the wrong references. Nothing dramatically what would change the interface by itself, but it gets maybe it's the implementation. If you do the implementation of this interface, you think about why is it like that done? This we try to fix with the Neo version. So the scope and with OPC and PackML was or is still quite huge and large. So it goes from top-level enterprise down to the machine and even machine communication with each other. So that means M to M and M to MES or to line controller, things like that. So we also was thinking, how we could do that. We focus now here down on the PackML by itself, and now I type a little bit deeper in the results of the PackML specification, how it is now today developed. You can have an instance system. This is always in OPC UA. You have a type system, and then you can have an instance system. The instance system represents your real physical machine or thing what you want to represent with OPC UA. In this case, in the upper level, one server represents only one physical machine. The second example is a system 2 here. represents at the moment 3 physical systems. So with OPC UA, you are not only, you say, oh, you have one maybe PLC, you can only build one physical machine behind. No, you can have multiple if the PLC or your computer or whatever is big enough for this model. The next one, this is a base object type, the PackML base object type, which is, and now we go a little bit to the type system. So from the instance, you have some physical thing here, and now you go to the type and describe how this thing looks, how your interface will look then in the instance later on. The base object type, there you have an admin object, status objects, there you have optional variables, there you have mandatory variables, and of course that was also a very big discussion, because maybe, you know, in the older time you had a handshake and now you have methods. Also the people needed to understand what is the value of an OPC UA method. That was not so clear this time. Remember, it's 2 years ago we started. Now we focus state machines. That was also a very big discussion, because they thought if you have a state machine, this is just how the state machines looks outside. I will show later on an example. You can have it also printed on a paper. This is only how it looks. You have not to implement it exactly like that, because you can just move through some states, things like that. That was I would say, a heavy discussion. It was a long time that we really figured out, yes, it is worth to make it with a standardized ESA 88 state machine and build it up in OPC UA. Therefore, also you can have, as a finite state machine, not always you are in the same production cycles. You can show the available states, you can show the available transitions, which are currently in the operating mode available. Just as an example here, when you represent it, for example, you have here a state machine on top. That's, top left is paper. This is a OMAC PackML version 3 base state model. And if you look with the OPC UA client to the state machine, you see how this interface is represented in OPC UA, and you can find all the transitions, all the states are there. So that means from paper, you start, we take as base the PackML base state machine model and modeled it in OPC UA. As I mentioned a few sentences before, you have some different modes in your machine. So you have one big state machine, but you say, this only valid in production, or maybe my machine does not have those states, but still I have a very complex or looking complex state machine in front of you, and I have different operating modes. What should I do with them? Like maintenance mode, like manual mode, no clue. Also no problem. Depending on the machines, what I've shown before, the available states and available transitions will exactly show from the model what is actually really valid in OPC UA and what is it doing at the moment. For example, this one is now at the moment in execution. And it's nothing else than an interface, has nothing to do with the real implementation behind. That's just some kind of mapping. Oops. So the structure then from the PackML object type, there you have I pick out 2 or 3 things. What you see here, you can see the current speed of the machine. Before it was really just a float or real, but now you can also have engineering units as properties on this thing. That means you see with the engineering units, it's 1,000 pieces per hour, per day, or it's 100,000 liters per second, whatever. But now you can see as a client, oh, it's not just a float value, and I need to know what is the real unit. You can represent it in OPC UA. And I think that is also a very great advantage for those that you can say to a variable, it has a property engineering units, and you see directly, if you look with a client, you know what it is. It's temperature, it's float, it's round per minute, whatever. On the other hand, you have then also, of course, a list of lot of parameters. And with the types, here, for example, this is a PackML descriptor variable type. Here you can describe each parameter, what it means. It's not just a pack tag, what you say, it's a value between 10 and 20. So you can say, yes, this is my parameter for maximum speed, for minimum speed, for whatever reason, or whatever you want to have as a parameter in your machine here. Then the admin object was also something, administration of PackML machines, so we decided, yes, let's make our own object by itself. So everybody know, if he looks to that, he makes some administrative things in a machine and not just writing some values, and it's surprising that the machine is speeding up, for example, or stop production, whatever. And of course, you can see, oh, something happened in my machine. And why? Why did the machine stop? You get also stop reason. That means something like alarming, for example. You have a problem and you get some explanation why it is doing it and what you can do then after that if it stopped. So things like that, that was also, yeah, was a heavy discussion there, but at the end, they was then also trained the people and said, yes, it makes really sense to make it full-blown OPC UA, because if we do it the halfway, we will not get the success what we want, because people know they get trained with OPC UA. VDMA started this time with their companion specs. Everybody talking about companion specs, and say, no, oh, a companion spec is an interface, and why should I have a lousy interface if the others have better and more comfortable interfaces? That was also a little bit the thinking around with PackML and the OMAC group, but at the end, everything is okay. And the next one was also something with classic data transfer. So what you do usually, you start a transfer of parameters, you say ready to transfer, then you say, okay, give me something, then you get the data, then somebody say, yes, everything okay, continue. The problem always there is typical. Consistent data transfer in larger, if you want to transfer a larger amount of data, so that the data are consistent to your application program and get it transferred, and also consistent, get it into your other application program. And maybe somebody know of that, the big and little endianness, so the bytes and words are shifted, and so you write one and get billions back on the other side if you have that wrong on the other side. Yeah, and there we said, okay, all those data transfers which we know, we will do OPC UA method calls. A method call is something application can collect, send it consistently to the application program. The application program knows, oh, hello, here is a method call. Take all the values there, operate with them, and send us a result back. Okay, or I don't know, wrong. But this is consistent, really consistent on both sides. Yeah, current situation for the PackML companion spec was released in 2018. Siemens was the first OMAC company that adapted these companion specifications in our PLCs. A live demo at Hanover was last year in April, and Pack Expo last week in Las Vegas in September on Siemens hardware. And also, as we know, Beckhoff is close to showing an implementation of PackML OPC UA companion specification, very near future. And the work group, as I mentioned, we had to fix a little bit something, is reactivated since a month ago. Yeah, PackML, line of the future, like OMAC PackML thinks it would be, you have an OPC UA network with PackML OPC UA on this network, and every PackML machine has this interface, and so for everybody benefits on that. And the next generation of packaging lines, I believe by myself, I'm more or less a technician, not a speaker, will be natively capable of full integrated PackML with OPC UA, I believe. And also the state machine, the ISA 88 state machine, is taken over with Weihenstephaner standard. This is for milk and cheese production, more or less, as Andreas, I think, mentioned it before. Yeah, so that was so a little bit from where we were starting, how many discussions we had, and what is at the moment the situation. And personally, I believe they made a good job. Thank you. And do you have any questions?